Alright, so welcome back to another lesson or to another video, and in this video we are going to be solving these tutorial sheet questions. Okay, so this is the latest tutorial sheet, and it's the tutorial sheet for vectors. So we're going to be solving some of the challenging questions in the tutorial sheet, which is from question 9 to question 12. I know there are many questions like from question 1 to question 8, but these have been solved. The solved tutorial sheet is on A Plus Academy app. For you who have subscribed to our application or our tutorials, you must have access to the tutorial sheets. Okay, so the majority of the students have requested that I kind of like record a video solving some of these questions, and then especially the last one. So if you don't understand how to solve any, then this video is for you. Okay, so now listen, this video I'll focus on solving, not teaching. If you want to learn, if you want lessons, we have our application, we have our app where you find video lessons. That's where the knowledge is. So for this video I'll be just applying the knowledge that I've already taught in the video lessons. Okay, so if you don't understand vectors, make sure that you subscribe to our tutorials, and you are going to find organized video lessons which you can learn and watch at own pace. Okay, so in this video I'll just focus on the solving part. I'll be just solving. Okay, maybe I might explain a little bit, but I'll be focused more on solving. So if there will be a concept that will be new to you, go and watch the video or the video lessons on our platforms. We have our platforms where you find the video lessons. Alright, so without any further ado, let's start solving. Alright, so this is the A Plus Academy app where you can find more of our videos. So you're on term 1, ph110. So under physics, you are going to find more videos under these topics. Vectors, there are all these videos which you'll get to learn at your own pace. In these videos we've taught everything. Okay, it's not just physics, even these other courses like chemistry, mathematics, and biology. Okay, so make sure that you contact me to have access to our simplified video lessons on the A Plus Academy app and get to learn at your own pace. These videos are pre-recorded, so you no need for you to attend any online lessons. You just watch from anywhere whenever you want and learn at your own pace. Alright, so we have a question here. So they're saying that determine the direction cosine for point in space given by. Now what are they talking about? So first of all, before I even proceed with solving, I want to walk you through some of the concepts that we'll be using to solve the questions that we have from question 9 to 12. So we'll be using concepts under three-dimensional vectors. Okay. So now in this video, I'm not teaching it like I said, but I'll walk you through some of the important concepts that we're going to use to solve these questions. But if you want full information on vectors, make sure that you go and access them on our app. We have an application where you find pre-recorded video lessons where I've taught everything under vectors. What I'll give you in this video, just like 10% or 20% of what you need to know. The rest has been taught in our video lessons. So let me just walk you through some of the concepts. So what we have here is a way in which you can describe a vector. So let me show you what I mean. So we have two types of vectors. They are what are called two-dimensional vectors, which the majority of you know, and the three-dimensional vectors. Now, what are three-dimensional vectors? So these are vectors which occupy three planes or three axes. So let me begin with what you already know. You already know the two-dimensional vectors. For example, this one. If you look at this vector, you can tell that it's only occupying this plane or this axis, the y-axis, and this axis, which is the x-axis, right? Now, what if I tell you that a vector can also occupy three axes or three planes, where the other plane is this one, and this is called the z-axis. Okay, so whenever you have a vector occupying these three axes, we can call it a three-dimensional vector. Now there is a way in which we can describe these vectors. So now listen, you can describe a vector by mentioning its components. This is a vector here. It has components in the x and components in the y. So if a vector also occupied the z-axis, it means that it's going to have component in the z-axis as well. So for instance, let's say that the component in the x is a, the component in the y is b, and the component in the z-axis is c. So let me begin by describing the two-dimensional vector. So there are two ways in which you can describe a vector, or two notations that you can use. So the first one is the one that we have used in that example, whereby you can mention the x component, y component, and the z component. So that, for instance, let's say we have this vector here, which is only occupying the x and the y. So I'm going to say, on the where this x, I'll just put the component in the x, which is a. Where this y, I'll put the component in the y, which is b. And now this vector, it is not occupying the z-axis. Okay, it's not occupying the z-axis, it's only occupying 2. So you just put 0 here. Have you seen? Now I've just showed you how to describe a vector which is occupying only 2 axes. Now what if it's occupying 3, even this axis? I'll show you a good example, I think on the last question, of how a vector looks like if it is occupying the 3 planes. Okay, so like this vector, how do you know that this vector is occupying the x and the y? Because this vector is moving from here to here. So for it to move upwards, it had to move along the y-axis, and for it to move in this axis horizontally, it had to occupy the x-axis. So since it has only used 2 planes or 2 axes for it to reach in, for it to move from this point to this point, we can say that it is 2-dimensional. Now the 3-dimensional vector, for it to move from this point, it is also going to occupy this z-axis. Okay, apart from the y and the x, it is also going to occupy the z-axis for it to reach to its final point. I'm going to show you a good example. Let me show you of how a vector looks like if it is 3-dimensional. So this is a cube. So we have this cube here. So an example of a 3-dimensional vector is this vector, vector E. Vector E is moving from this point. Now it had to move horizontally, then it went upwards, right? But again, it also occupied this axis here for it to reach to this corner. Look, it's like it is moving from this edge. If you have ever seen how the box is, it has moved from this corner to this corner, from this edge to this edge. So for it to move from this edge to this edge, it didn't just take the y and the x axis only, it also took the z axis for it to reach here. So this one, we can say it has occupied all the 3, or I mean it has used all the 3 planes. Okay, but if you look at this other vector here, this vector, it has only used the z and the y. It has not used the x. Okay, I'm going to show you when we come to this question 12 actually. So let's come back here. Right, so now let's say that we want to describe a vector that has used y, x, and z axis. So we are going to say the component in the x is a, the component in the y axis it is b, the component in the z axis it is c. Have you seen? That is if the vector given is also occupying the z axis. So this is one way in which you can describe a vector. Now the other way, let's say I want to describe this vector using another way. The other way is using the notations. So you need to know that the x component is denoted by the letter I. the y component is denoted by the letter J, x, y, and the z axis is denoted by the letter K. Okay, so instead of having to put them in parentheses like this, we can just say, so A, this component A is in the x-axis, denoted by I. Then you separate them by plus. Then you say, we go to the next one, which is the y-axis. This B is denoted by, the B component is in the y-axis, which is denoted by the letter J. So you put the component B and the letter J, presenting the y-axis. And then you say plus. Now this one, it is 0, like it's not occupying the z-axis. So just put 0k. So this is another way in which you can describe this vector. So this and this are the same. Let's come to this one. So this one, you can describe it as a component in the x-axis denoted by I, B component in the y-axis denoted by J. Since this one is a three-dimensional vectors and it is also occupying the z-axis or the z-plane, we are going to include it. So we're going to say CK, right? So this is how it goes. So now you need to understand this. So we can describe this vector in this manner as well. Okay. So this is one of the concepts that you should know. The other concept that you should know is the concept of the direction cosines. So if they tell you to find the direction cosine, they simply like describe the direction of the vector. Now, you need to understand that the angle between the vector and the x-axis is called the alpha, and this one, the angle between the vector and the y-axis, it is called the beta, and the angle between the z-axis and the vector, it is called the gamma. Gamma is presented like this, something like this. Some like writing like something like this, I don't know. Yeah. Okay, so these are the angles basically. There's alpha between x and the vector, beta between y and the vector, and the gamma between z and the vector. So now we can find these angles using these formulas. So let's start with the one for alpha. So you say cos alpha is equal to x over r. So x is simply the component in the x. R is the resultant. I'll show you the formula for resultant just a minute. Okay. And then the one for beta, you can say cos beta is equal to, so listen, since beta is an angle between the vector and the y-axis, so this angle is having an impact on the y-axis, right? So we get the component in the y over r. Same with this one, because alpha is having an impact on the x-axis, so we get the component in the x over resultant. And then the last one we say cos and cos gamma is equal to, so since gamma is having an impact on the z-axis, so we get the component in the z over the resultant. So these components you are seeing here, these y, z, are simply what is found here. This is x, this is y, this is z. So we just get these values and plug it. And now, how do you find the resultant? These are, how do you find it? So resultant, let's say you have a three-dimensional vector like this. So we say resultant is equal to coefficient of I, this is j guys, so coefficient of I power 2 plus coefficient of j power 2 plus coefficient of k power 2. So you just have to sum them up. Whatever you get will be the resultant. Now you only, if they tell you to find the direction cosines, just end here. But if they tell you to find the angle, the actual angle, like the alpha, make alpha the subject. So if they tell you to find the angle alpha, it's going to be, take cosine on the other side to be the inverse of cos x over r. If they tell you to find the angle beta, so they will tell you in the question. If they mention the angle, you need to go beyond this. If they just say find the direction cosine, just end here. And for beta, it's going to be cos inverse y over r. And then for this one, which is gamma, I'm forgetting the name. So cos inverse, this is inverse. You know how to find the angle, right? Cos inverse z over r. So these are the formulas that I'll be using throughout this video. Okay, so I wanted to familiarize you with these. These are just like a few concepts on vectors. But if you want full information, subscribe to our tutorials. You'll find where you are going to access full videos of our lessons on vectors, which are organized, and you get to learn at your own pace. Alright, we have our application where you find pre-recorded videos. Whatever I'm giving you right now to solve these questions is just 10%. The remaining percentage, you access it by watching our videos. We have solved more questions. Okay, so let's proceed. Okay, so we go back to question 9. So determine the direction cosine for point in space given by. So let's solve this one. I'm sure by now you even know the formula to use. Alright, so we have question 9. So they have given you this vector, which they have described in this manner. So we can also write this as, this is the component in the x, so we put I, the component in the y, so we say 2j, the component in the z-axis, so we say negative, and k. So I can write this properly as 2j minus k. Okay, so now listen, they want you to find the direction cosine. So first of all, I'm going to find the resultant because I'm going to need it, if you remember the formula. So what did we say? Get the coefficient of I raised to the power of 2 plus coefficient of j to the power of 2. Remember the formula, r is equal to x power 2 plus y power 2 plus z power 2, where these are the coefficients, or they are simply the numbers coming in front of I, in front of j, in front of k, which is negative 1. So continue, plus negative 1 over, negative 1 power 2. So r is going to be equal to, so we'll simplify this. 4 power 2 is what? 4 power 2 is simply 16, plus 2 power 2 is simply 4. This one is just going to give you 1. Alright. Alright, so we say r is equal to square root of 21, because when you sum these up, you're going to get 21. So we have the resultant. So let's find the direction cosines. So let's start with the one for alpha. So we say cos alpha is equal to x over the resultant. So cos alpha is equal to, x is simply the component in the x, which is this one. Remember, this is x, y, z. So here I'll put x, which is, or if you want to get whatever is coming in front of this one. So it's going to be 4 over, what is r? R is square root of 21. Alright, so see, let's go for the one for beta. It's equal to y over r. So cos beta is equal to, the component in the y is 2, r is square root of 21. So this is the direction cosine for beta. And then let's go for the one for, remember we have three angles, alpha, beta, and gamma, right? So let's go for the one for gamma. I don't know how you write the symbol for gamma, if it's something like this. So, wait, but it is written like this. Gamma. Gamma, I think the right way of doing it is like this. Don't bend this, it will look like Y. So, cos gamma is equal to Z over resultant, right? Cos gamma is equal to, so the component in the Z axis, that one is negative 1 over resultant is square root of 21. Alright, so this is how we do it. So we have solved the first question, question 9, and let's go question 10. So question 10 is saying that determine the direction cosines for a line joining 2 points, point P to point P2. So this one is quite tricky, but it is easy if you understand. So let's quickly solve this question. Alright, so let's go question 10. Let's go question 10. So we have a line joining 2 points, P1 and it is so meaning that the line was moving from P1 to P2, right? So these are basically vectors. So now if I start drawing diagrams, you'll be confused. Let me just give you the important point here. So now listen, for us to find the direction cosine for the line that they want, we don't need to have we won't be required to use two values. We need to end up with the final vector representation. So meaning that we are going to find the difference of the component of the 2 points. So we are going to subtract two corresponding components. So listen, this is the x, y, x. I mean x, y, z. This is x, y, z. So now this is the final point, right? And if you remember, whenever you are finding the difference of 2 points, you subtract the final one, I mean the initial one from the final one, right? You start with the final one minus the initial one. So in this case, you're going to start with the x component from the final point, which is P point 2. So you're going to say this one minus this. This one minus this. You start with the components in the final point. Which is this one. So you subtract this from this. Let me show you what I mean. So we're just going to do this. To find the point that we are going to use for our calculations, we are going to do this. So we need to find the difference between this and this. So we are going to be starting with the final point. So it's going to be 6 minus 4. We are getting the corresponding ones, the x and the x. So whatever we are going to get here, it will be our I. So we say plus this minus this, 3 minus 2. Whatever we are going to get here will be our j. Then this minus this, so it's going to be 5 minus negative 1. Whatever we're going to get will be our k. So p is equal to 6 minus 4, that is 2, right? This will be j. This will be positive, so it will be 6, right? So we are going to have, here we have j, so we have 6k. Alright, so now we are going to use this vector for our calculations to find the direction cosines. So we start with the one for cos. So we say we start with the one for alpha. So we say cos alpha. Now wait, we are going to need the resultant. So let me first find the resultant, then we find the direction cosines. So take note of this one. This is what we are going to be using. So now I'm going to find the resultant. So resultant is simply equal to the coefficient of I 2. For now, forget about all these. We are going to be using this for our next calculations. So we say 2 power 2 plus 1 power 2 plus 6 power 2. So R is going to be equal to, here we have 4 plus 1 plus 36. So R is equal to 41. Right? Now let's find the direction cosines. So we start with the one for alpha. Remember that the component in the x, which is 2, right? And then cos beta, the component in the y is simply 1. And then the component for, which is gamma, right? Component in the z, which is 6 over resultant. So we've just solved question 10. So let's go to question 11. Question 11, they are saying that determine the angle that the line in question above make with the x, y, and z. So this is where I told you that if they specify that find the angle, that's why you use those other formulas which I showed you. So we are going to carry on from our direction cosines. So this is question 11 where we are at. So we are going to do this. So we say question 11. So now you're just going to make alpha the subject of the formula, and it's going to be alpha is equal to cos inverse 2 over square root of 41, which is 2 over square root of 41. So the angle alpha is going to be equal, when you punch on the calculator, it's going to be equal to 71.8 degrees. We proceed, we come to this one. So we say cos beta is equal to, no. I mean, when you make beta the subject, we're going to have cos inverse is equal to 1 over 41. So beta is going to be equal to 81 degrees. So we come to gamma. So if you make it the subject of the formula, it's going to be cos inverse 6 over square root of 41. So y is equal to, this is going to give you, it's going to give you 20.4 degrees. So this is how you simplify the angles. Okay, so now let's go to question 12, which the majority of you are like struggling with. But if you've understood what I've just done for question 9, 10, and 11, probably question 12 won't be a challenge. Okay, so we have question 12, which the majority of you are having challenges with. So the question is saying that in the figure below, vectors B and C are intersecting face diagonal. We have vector B and C are intersecting face diagonal, facing diagonal lines which are intersecting at this point of a cube or of an edge A in the plane XY and YZ respectively, with respect to a frame of reference erected at the point of intersection of the vector and edges of the cube as the axis. Find the following: the value of B dot C, vector B dot C. So listen, from here to, let me show you. So all this statement here, they are just describing to you what is here. They are just telling you that there are these vectors. These vectors are diagonal. They are intersecting at this edge. Now this is a cube. So this point where they are all intersecting is what we are calling the reference point. And then these are the edges. These are the edges. This edge, this edge, this edge. And now this is a cube. The moment you hear that something is a cube, there is something that you should know. There are some properties of a cube. If it is a cube, it means that this side, have you seen there's this side here, there's another side here, there's another side here, there's another side, like these are like the faces. If you've seen the box, if you've seen how the box look like, let me show you the box. Okay, so I'm going to use this box to make you understand. So have you seen this box? This box has got sides, right? It has got this face here, there's this face, and this face, okay? And not just these faces, there are also other faces like the top and the bottom one. So I want you to see this diagram the same way you're seeing this box. This is presenting the face here. This side, this is presenting the face which is on this side, and then this is presenting this face, and then this bottom triangle, rectangle, the bottom rectangle, I don't know if you should say a rectangle or square, it is representing this face here. So this has got how many faces? There's this face 1, face 2, face 3, face 4. Okay, so we've counted the faces that are in this region, and they are also the upper and the bottom faces, right? The two. So it has 4, 5, 6 faces, right? If you count the faces, there's 1, 2, 3, 4, 5, 6. So 6 faces. So these are the dimensions I'm telling you about. These are the sides. So now this box I'm showing you is different from what I've drawn here, because here they have said that what we are having is a cube, meaning that these faces are having same dimensions. So meaning that this face is having A, even this face is A. A is the distance. It's like the distance of each face. So they are saying that the distances of all the faces are the same. They are of equal distances. So the distance from here to here, it is A. From here to here, it is A. From here to here, it is A. Here to here, like they are having same distances. That's the point. I don't know if you get it, but yeah. And now let's try to answer some of the questions. So if you see this diagram here as the box that I've showed you, now just at this diagram, they have also showed you the inside parts. Okay, so we have these vectors. So now I want you to be viewing this diagram the same way we are viewing this box. Okay, just that this diagram here, they are also showing you the inside parts. So like it has 3 vectors. There's vector E, C, B. So if you look at vector B, obviously vector B, it is like let me show you the box again. Have you seen this box? So vector B is like they have gotten this face here, which is this one. Have you seen? Then they are just showing that it has moved from this point to this point. Vector B from this point to this point. Now on the face which was on that other side, in vector C is simply from the edge, this edge here, this one here, to this point. In vector E is from that edge here to this edge here. So this edge is for the face which is that other side, to the edge which is here, the upper edge on this side. So if you see it like this, it will be easy for you. Okay, and don't forget the axis as well. I hope this won't make you be confused more, because if you're able to visualize this question the same way you're able to visualize this box, then it will be very easy. So let's solve. So we have value. They want you to find the value of BC. This Alright, so this is the A Plus Academy app where you can find more of our videos. So you're on term 1, ph110. So under physics, you are going to find more videos under these topics. Vectors, there are all these videos which will get to learn at your own pace. In these videos, we've taught everything. Okay, it's not just physics, even these other courses like chemistry, mathematics, and biology. Okay, so make sure that you contact me to have access to our simplified video lessons on the A Plus Academy app and get to learn at your own pace. These videos are pre-recorded, so you no need for you to attend any online lessons. You just watch from anywhere whenever you want and learn at your own pace. Alright, so I'll be using this diagram to explain since it is much bigger. So let's solve the first question. They want us to find the value of B. The value of alpha dot. The value of vector B times vector C. I'm solving the alphas and the beta, so they are still on my mind. So here they want you to find the dot product of vector B and vector C, which is this one. So if you've seen, vector B is moving from this edge to that edge. On that other face that is there, if you try to visualize this as using the box which I showed you as an example. So, and again, remember one thing. The distance from here to here, it is still A. Because this is a cube, all the dimensions are the same. Here there will be A. Even here, the distance from here to here, it is A. It is A. So like, all the dimensions are having this distance of A, because it's a cube. So if you see, vector B is moving from this point to this point. So meaning that this one is only using which axis? The Y and the X. I'm sure you know how we are going to formulate the vector B. And then vector C is moving from this point to that point. Now vector C is only utilizing the Z-axis and the what? And the Y-axis, because it hasn't passed in the X-axis. Okay? So here's how we are going to describe them. Let me show you. So I want you to pay attention. Once you just understand this part, then this question will be easy for you. So let's start. So vector B. So vector B, moving from this point to this point, only utilizing the Y and the X axis. Now, remember the notation that AI plus BJ plus CK, right? Do you remember this? Remember this notation. We're going to use this notation to describe vector B. So now let's describe vector B. So A is simply the component in the x-axis of vector B. So the component is from here to here, simply the distance. So the component that is in this direction is what? It is A. So the component in the x is simply A. We come in the B. We come in the y-axis. So the component in the y-axis is what? It is also A. So I'll still put A because it's the distance from here to here in the y-axis. So I'll simply say A J plus, we go in the z-axis. Now we don't even have to go there because vector B has not passed in the z-axis. It does not utilize this axis in its movement. It has only moved along the y and x axis. So I'll just put 0k. Okay, so this is our vector B. Take note of it. Now let's find vector C. So if you remember this notation, vector C is this one, this vector here. Vector C has only utilized y and z axis. Okay, vector C has only utilized y and z axis. So let's start. What's the has it utilized any component in the x axis? No. So I'll just put 0 I. Then I'll come in the y axis. Has it utilized the y axis? Yes. What's the component in the y axis? Since all the sides are the same, I'll still put a. A is simply presenting the dimension, that the dimension is simply the same everywhere. So this is the component in the y, and I'll put j. How about in the z? Of course, it has utilized this distance here. So I'll put a k. You see? So we have vector B and vector C. Now they want you to find the dot product. Remember, the formula for dot product is the magnitude of vector B times magnitude of C times cos. Now, do you think we are going to use this formula? So, this formula, look, they want us to find this, right? Now, this formula can be used only if we are given the angle. Since the angle is not given, we are just going to find the dot product by simply multiplying these two vectors or multiplying their coefficients. So it's going to be the vector of B, which is this one, times the vector of C, 0I plus AJ plus AK. So A times 0 is 0 plus. You multiply those corresponding components. A times A, it is A power 2. A times 0, it is what? A times 0, it is 0. So the dot product is simply 0 plus A power 2, it is A power 2. A power 2 plus 0, it is still A power 2. So we have found the dot product. As simple as this. So it is knowing how to come up with the vectors. So the next question is saying that find the angle between B and C. Between B and C. So this is where now we are going to come back to this formula. This formula here. So our goal will be to make cos theta the subject. So remember, the dot product of B and C is equal to their magnitudes times cos theta, right? Let me make cos theta my subject of the formula, over. So cos theta is going to be equal to dot product of B and C times magnitude of B and C. Have you seen? Now you already know your dot product. All you need to find is your magnitude for B and the magnitude for C. So let's find that. So magnitude for B is equal to, what's the vector B? The vector B, where is it? It is here. So get the coefficient. The coefficient of, look, we are here. We are using this one. So we get the coefficient for I, which is, so coefficient for I is A power 2 plus coefficient for J is also I power 2 plus coefficient for K is 0. So we can sum this up and we are going to get 2a power 2. We can simplify this. We can simplify this. The magnitude of b, we can write this as, now this square root is going to cancel this power 2 that a is having, and you're just going to remain with square root of 2a. So we have found the magnitude for b is square root of 2a. Let's also find the magnitude for c. So c is this one. So we are going to get the coefficient of I raised to the power of 2 plus coefficient of j raised to the power of 2, coefficient for k raised to the power of 2 is equal to 2a power 2. So this is going to be square root of 2. Remember this, okay, we can also write this as, in the square root is going to cancel the 2, we are going to remain with, so it's going to be square root of 2a. So they are just the same, they are having the same magnitude. So your job now is to substitute where this b dot c, put this, because we found the dot product. Where is the magnitude for b, put this, the magnitude for c, put this, then simplify and find the angle. So let's substitute. So we have cos theta is equal to the dot product of b and c is, remember we found it to be a power 2, right? The magnitude of b, we found it to be square root of 2a times the magnitude of c, square root of 2a. So now, if you remember the concept on radicals, we said if we multiply two similar stuffs, two similar radicals, we just get 2. The square roots are going to cancel, and 8 times a is going to be a power 2. So a power 2 and a power 2 will cancel, and cos theta is equal to 1 over 2, right? So theta is equal to cos inverse of 1 over 2, right? So I want you to punch this on your calculator. Punch it on your calculator and tell me what you're going to get. Okay, so what you're going to get is that you're going to find your angle to be 60 degrees. This is how you do it. So let's go on the next question. So the next question is saying that, question C, the components of the vector d. So it's like we have come up with a vector d which we can't see, but they're saying that whatever this vector is, such that d is equal to b times c, the vector b times, basically they're just saying that d is equivalent to the cross product of b and c. Now, how do you find the cross product? That's why we use the matrices concept. So we already know the value of b and c, right? Vector b and c, we know them. So for us to find vector d, which we don't know, we are going to find the cross product of b and c. If you don't know what the cross product is, I've already taught this in my videos. Make sure that you subscribe to A+ Academy app, our tutorials, where you access organized video lessons. Okay, so let me find, so for you to find d, just find the cross product of b and c, of vector b and c. Whatever you get will be vector d, and that will be your final answer. As simple as that. Okay, so we are finding vector c. Vector c, right? And question C, we are finding vector d, which is equal to the cross product of vector b and c. So try to recall that vector b is equal to, we found vector b, if you remember. vector C is equal to so now for us to find the cross product, we are going to find the determinant, some sort of determinant. So first we are going, in the first column we are going to write the notations I, negative j, and k. In the second column we are going to put the coefficients of the vector b, where the first coefficient is a, this one. Second coefficient, which is coefficient of j, is a. Third coefficient is 0. And then here we're going to, in the third column, we're going to put the coefficient of j in the vector c. Arrange them in order, starting with the first vector to the second vector. So here I'll put 0 as the first coefficient. Second coefficient, which is of j, is a, and then this one, coefficient of k in vector c, which is a. We even do this. Now, how do you find the determinant? So first, we're going to write this I. We need to find the matrix, or the values that we're going to use to find I. Here's what I mean. So first write I and do this. So where is I? Draw a cross like this. If you were to draw a cross, imagine where this I draw a cross. Which values have not been crossed? Look, on I, if I draw a cross like this, there are some values which have not been crossed. These values include these values which have remained here. So these will be in our matrix. So these values here will be in our matrix, which we are going to use to find the coefficient of I. So here I'll put what has remained after crossing the I. Like a cross, that cross that you wear, the cross, like a plus, then what will remain is what you're going to put here. Here I have A, this is A. So we have A, 0, and A. We do this. Then we come to J. Since J is having a negative, I'll say negative J. So I'll go where J is. If I were to draw a cross where J is, if I draw a cross on J, imagine a cross on J. Which values have remained which haven't been crossed? There is this value, these values here, and these values. So these values which have remained are going to be in our matrix, which is A, 0, 0. I know maybe 0. Look, the only 0 that we have is this one and this one. The rest are A's. This is A and A. Yeah, so it's going to be A, 0, 0, and A. Okay, and then we say plus K. We come now where K is. So imagine on K, if you had to draw it across, draw a cross like this. This is what I'm meaning when I say cross. What values have remained? These values here, right? So these values will be in our matrix, which include A, 0, and A, right? So now find the determinant, whereby you multiply the major diagonal, you subtract the minor diagonal from the major diagonal. So it's going to be A times A. A times A is going to be A power 2 minus A times 0 to be 0. We come to J. A times 8 will be A power 2 minus 0 times 0 to be 0. We come to K. A times 8 will be A power 2. 0 times 8 will be minus 0. Okay. Right, so here we have A power 2 I minus A power 2 J. I'm just multiplying with what I'm getting after simplifying what I have here. So here we're going to have A power 2 K. So this is vector D. So we have just found vector D. So now, the last question, we are saying that direction cosine. Find the direction cosine of the body diagonal presented by vector A. So for you to find this one, you just need to know your vector A. Let me get that other diagram. Where is it? Okay, let me pause the video. Okay, so if you see where vector E is, this is vector E. So vector E, we are moving from this point to this point. So vector E, for us to move from that edge to this edge, we have not only used the y-axis and the x-axis, we have also utilized the z-axis, because we've moved along the z for us to move from that corner to the upper corner, facing to this upper corner here. So where have you used the z? We've used the z-axis when we are coming now towards this corner, because we had to use some sort of distance, which is here. And we used the y-axis when we were going upwards. We used the x-axis when we were moving horizontally, going this direction. So we've used all the three axes. So this is a three-dimensional vector. So this vector can be presented as, since all the sides are a, so it's going to be a I plus a j plus a power k. Have you seen? So question D, they just want us to find the direction cosine. So we figured out that vector E is ai plus j plus k, right? So we are going to, so first let's find the resultant. Resultant is equal to a power 2 plus a power 2 plus a power 2. So r is equal to, so it's going to be 3a power 2, right? Which when you simplify is going to be 3a, just a, because this a power 2 will be cancelled by the square root. So remember, let's start with the one for alpha. So for alpha is going to be a over 3a, right? For beta it's going to be a over also 3a, right? Even for gamma it's going to be still going to be a over square root of 3a. So now the a, you cancel it, right? So the direction cosine for all of them is going to be, because they are the same if you've observed, so it's going to be 1 over square root of 3. 1 over square root of 3, because 1 over square root of 3. Okay, so this is how it's going to look like. Okay, yeah, so this is how you go about these questions. So if you want to know more about vectors, make sure that you subscribe to our tutors. Contact me on this line 07777 25414 to subscribe to our tutors, where I explain everything bit by bit, the same way I've explained this question. And you don't just access our lessons for physics, you also access our lessons and simplified videos for mathematics, chemistry, and biology, apart from physics. So subscribe to our tutors and make sure that you install the A Plus Academy app to access our simplified video lessons. Okay, we've taught all the NS syllabus. You just get to watch at your own pace. And most importantly, subscribe to the YouTube channel. Click on subscribe to be accessing the videos that I post on this channel. And I hope that you've understood. See you in the next video. Alright, so this is the A Plus Academy app, where you can find more of our videos. So you're on term 1, ph110. So under physics, you are going to find more videos under these topics. Vectors, there are all these videos which will get to learn at your own pace. In these videos, we've taught everything. Okay, it's not just physics, even these other courses like chemistry, mathematics, and biology. Okay, so make sure that you contact me to have access to our simplified video lessons on the A Plus Academy app and get to learn at your own pace. These videos are pre-recorded, so no need for you to attend any online lessons. You just watch from anywhere whenever you want and learn at your own pace.